Welcome back. Here's video number 2 for section 5.3. In the previous video, we were able to find a bunch of information about a polynomial once it had been put into factored form. We were able to find the roots or the zeros. We were able to find the degree, the leading coefficient, we even in behavior, sketch graph, all that kind of stuff. So how can we do that if we don't have it in factored form? Well, number one, we just factor it. So we're going to practice that. I picked this one because hopefully you guys remember, or maybe you need a little refresher on factoring by grouping. If you don't remember this, there will be a video in the helpful video section, or you could just go to YouTube and Google factoring by grouping. But let's go ahead and factor this guy by grouping. F of t equals t cubed plus 2t squared minus 9t minus 18. And the first thing I'm going to do is I'm going to write this as plus negative 9t plus negative 18. So I have everything all added together looking like it should for a polynomial. All right, how does grouping work? Remember, we group the first and second term, and you group the third and fourth term. Then you pull out any common factors from the first group. Well, the first group has t squared in common. And that leaves me with t plus 2 if I multiply it back out. So t cubed plus 2t squared. And the second group has negative 9 in common, and that leaves me with t plus 2. Now you make sure you work this out so these guys are the same. The second quantity in each group should end up being the same. Let's factor that quantity out of the whole expression. So I factor t plus 2 out front. In the first term, it leaves me with t squared, and in the second term, it leaves me with minus 9. All right, now we are almost done factoring. We need to factor one more time. The t plus 2 is totally factored. But t squared plus minus 9 is a difference of squares, right? Difference of squares. And so this factors as t plus 3, t minus 3. So now we have put this into factored form. Now, in part B, we can list our zeros and their multiplicities. So part B, well, we have our zeros are t equals, let's rewrite this just for fun. F of t equals t minus negative 2. Remember when we wrote the roots, we wrote t minus negative 3 and then just t minus 3. So our roots are t equals negative 2, t equals negative 3, and t equals 3. Those are our zeros, our roots, our horizontal asymptotes, however you want to list those. And they each have multiplicity 1. Multiplicity 1, multiplicity 1, multiplicity 1. And therefore, the degree of the polynomial is 1 plus 1 plus 1 equals 3, which we actually probably already knew by looking at it in the non-factored form. We can see that it was t cubed. All right, what is the degree of the polynomial? Is the leading coefficient. What is the leading coefficient? It's equal to 1, right? Leading coefficient. All right, what is the in behavior in formal notation? Well, this is a degree 3, so this is going to behave like x cubed, right? Degree 3 with a positive leading coefficient is going to behave like x cubed. It's going to look like that, right? Okay, that was a really bad x cubed. There, I fixed it a little bit. So the limit as x goes, oh, no limit. This isn't calculus. What am I saying? As x goes to negative infinity, as t goes to negative infinity, f of t goes to negative infinity. As t goes to positive infinity, f of t goes to positive infinity. All right, let's sketch our good enough graph. I didn't get the vertical intercept on this one. I'm going to do that on my own, even though it's not being asked. This is part D. This is part C. I'm all over the place today. All right, we didn't ask for the vertical intercept, but I'm going to go ahead and figure it out anyway. So what is my vertical intercept? Well, I need to find f of 0, right? That's going to be 0 cubed plus 2 times 0 minus 9 times 0 minus 18. All right, so let's sketch our good enough graph. All right, we have 3 zeros. We have negative 3, negative 2, 1, 0, 1, 2, 1, 2, and positive 3. There's our 3 roots, or our 3 zeros. We know we're equal to negative 18 at 0, so I'm going to do that. We know our in behavior goes to negative infinity this way after our last root, and goes to positive infinity after our largest root. All right, they each have multiplicity 1, so we're just going to go through each of them. So this has got to go like that. We got to go down and hit this, and then we come back up like that. There's our graph, our sketched graph of the our function f of t. All right, let's say we're given a graph instead of given the function this time. Can we still find out all this information? Up to this point, we've created the graph. Now can we look at the graph and deduce some information? I think we can. Let's give it a try. So here's my graph. Let's go ahead and see if we can figure out all the zeros. Well, I see a 0 here, I see a 0 here, and I see a 0 here. So I have x equals -3 as my 0, x equals -1, and x equals 4. And remember, my zeros are the same thing as my horizontal intercepts. So those are my 3 zeros. Let's think about their multiplicity. Let's look at x equals -3. Remember, it comes down and it goes back up, so we know it has to have even multiplicity. I mean, it could be a 4, but we're just going to put the smallest number down, so we're going to say multiplicity 2. If we look at -1, it looks linear. It looks like a line through there, so that's going to be multiplicity 1. Crosses. This, oops, what just crazy things just happened. Hang on, I bumped something. Okay, here we go. Back to 4. If you look here, it looks like x cubed. It sort of flattens out as it goes through 4. So we know that guy has multiplicity 3. You really won't be asked to guess 4, 6, 8 multiplicities. Really just, is it 2, a 1, or a 3? All right, find the vertical intercept. It looks like it's right here. And we need to look at the scale of the graph to make sure we can figure out what this is going by. Well, from -80 to -160 is 80. Halfway between 80 is 40. So I think this must be at -120. So this is over 0, down 120. Positive, negative, even, odd degree of the polynomial. What do we think? Well, let's look at the end behavior. As x, let me switch my colors to look at end behavior. As x goes to -infinity, this function is going to infinity. As x goes to positive infinity, this function is going to infinity. So which of our functions is that like? It's like x squared, right? It's like x squared. So we know that it's positive, leading coefficient. And we know it's an even degree polynomial. All right, how many turning points does this one have? 1, 2, 3, 4. Oh, what am I bumping down here that keeps doing that? It's driving me crazy. Sorry about that. There are 4 turning points. 4 is the turning points. So what is the least possible degree of this polynomial? So the least possible degree, well, it has to be more than 4, right? So 4 is not an option. So it has to be 6. What's a possible function for this graph? So let's go ahead and write our roots in. Okay, we're going to call this guy f of x. And we don't know the leading coefficient. Let's just write that as a for now. But we know it has x, a -3 root with multiplicity true. So x minus -3 with multiplicity 2. We know it has a -1 root with multiplicity 1. X minus -1, multiplicity 1. X minus 4 with multiplicity 3. All right, how do we work out that 0, -120 business? Well, we know the point in 0, -120. We don't know a, right? We don't know a. So let's plug it in. F of 0, we know, is equal to a times 0 minus -3 squared, 0 minus -1 to the first, 0 minus 4 cubed, and it's also equal to -120 because we read that off the graph. F of 0 is -120. So this is a times, this is going to be 3 squared, which is 9. This is going to be, let's just pause, this is going to be 1 squared, which is 1. This is going to be negative 4 cubed, which is going to be negative 4 times negative 4 is 16 times negative 4 is negative 64. And that's equal to negative 120. So now I need to figure out what 9 times negative 64 is, which I need to use a calculator for. $576. All right, so we have A times negative 576 equals negative 120. Divide both sides by negative 576, and these don't always turn out to be the nicest numbers. 120 divided by 576, I'm guessing it doesn't go evenly. No, it's not even at all. So A equals, well, let's just see if we can reduce that. 120 divided by 2 is 60 over 576 divided by 2, 288, which reduces more. Let's divide again by 2. 130 over 144, which is 15 over 72. I think we can keep going. Divide by 3, which is 5 over 24. So that's not the nicest coefficient, but it's not awful. So what do we think our function is? We think our function is this business with the A plugged in. So let me write it up here in black. And you guys can even go and check on Desmos that this actually matches the graph. That'd be a good exercise. We think it is f of x equals 5 over 24. I hope that was right. I hope I reduced my fractions correctly. I think I did. 5 over 24. X minus negative 3, so x plus 3 squared. X plus 1. X minus 4. Squeeze in a cube. All right. So we came up with a function for this graph based on reading the zeros, looking at their multiplicity from the graph, figuring out how many turning points and what the minimum degree could be, and then finally plugging in the horizontal intercept, the vertical intercept, so we can figure out a possible leading coefficient. All right. Let's talk about the last way to do this. We're going to talk about words to function to graph. So we're going to just talk in words first, and then we're going to try and come up with a graph. So we want a function for a polynomial of degree 5 with roots of multiplicity 2 at t equals 3 and t equals 1, and a root of multiplicity 1 at t equals negative 3. It has a vertical intercept at 0, 9. Then sketch a good enough graph. All right, no problemo. So let's do f of t equals, well, we don't know the leading coefficient, so let's just write down a. We know we have a root of multiplicity 2 at t equal to 3, so t minus 3 has multiplicity 2, and t minus 1 also has multiplicity 2. And a root of multiplicity 1 at t equal to negative 3. t minus negative 3 has multiplicity 1. All right, so let's simplify this just a little bit. F of t equals, we don't know a, t minus 3 squared, t minus 1 squared, t plus 3. All right, so we used all our information about our roots. That was used. We know it's degree 5, and that adds up because we have 2 plus 2 plus 1. And we know it has a vertical intercept at 0, 9. We haven't used this yet, so let's plug that in. F of 0 equals a times 0 minus 3 squared, 0 minus 1 squared, 0 plus 3. And we also know that it also equals 9. So this is equal to a times negative 3 squared is 9, negative 1 squared is 1, and times 3 equals 9. So a times 27 equals 9. A equals 9 over 27, which I'm pretty sure is a third. So our function is f of t equals 1/3 t minus 3 squared, t minus 1 squared, t plus 3. All right, we have everything we know to sketch a pretty decent graph. Let's go ahead and sketch it. So let's see, we have a root with multiplicity 2 at 3 and 1. So 1, 2, 3. Here's one root. Here's one root, both of those multiplicity, and also just a multiplicity 1 at negative 3. Negative 1, negative 2, negative 3. All right, what's our in behavior going to be like? What's a degree? It's degree 5, right? Degree 5. Leading coefficient is positive, so we're going to be like x cubed, right? Going to be like x cubed. So I know this is going to come up like that, and this is going to come up like this. All right, going through my roots, this one has multiplicity 2, so I know it's going to be like that. I know it can't cross the axis again until 1, or even touch, because otherwise I'd have another 0 there. So I'm going to have to go up, oops, come back down and go like that. Multiplicity 2 at 1. And, oh, I forgot 0, 9. I'm just going to call that 9. I'm going to go up there, cross 9. Sure, come back down, and I know this is multiplicity 1, so it's going to cross that like a line. So there's my graph. In behavior like x cubed, positive x cubed. My multiplicity 1, 0 at negative 3. My multiplicity 2 zeros at 1 and 3. All right, that's it for this section.